Hello. In this video we will discuss friction. Friction is a force that prevents objects from slipping on a surface. More precisely, friction is a force that a surface will exert to slow or stop the sliding of an object along its surface. There are two types of friction, one where the object is already moving and one where it is not. Let's first examine the motion of the object when it is already in motion. We will call this case the kinetic case, because kinetic means moving. Here we have a box sliding along the ground at some velocity. Almost all real surfaces have some amount of friction, so the ground is going to exert a frictional force on the sliding box, and this force will oppose the motion. That is why the friction force arrow is pointed in the opposite direction of the velocity arrow. Now the question is, how strong will this frictional force be? Well, here is the formula. This N is the normal force which the surface is exerting on the object. This other funny symbol is the Greek letter mu, which is like an M. It is called the coefficient of friction, and represents how much friction the contact between two surfaces produces. Its value depends on the surface. You can imagine that a surface made of ice will have a very low coefficient of friction, since it is very slippery, which means there isn't much friction. A surface like concrete, on the other hand, has a pretty high coefficient of friction, and objects don't slide along concrete very well. So let's actually figure out what the acceleration of the box is in this case due to friction. We will draw the free body diagram, which means we have to think about all the forces that are acting on the object. First, as always, we have gravity pulling the box down, with a strength of mg. Next, since gravity force is pushing directly into the surface of the ground, there is a normal force that has to balance that. Therefore, the normal force is pushing directly upwards with a strength of mg. Now, since the object is sliding rightwards, there is a frictional force towards the left. To find out how strong it is, we use our formula of mu times the normal force, which in this case is mu times mg. So now that we have all of our forces, let's figure out what the acceleration of the object is. Taking rightward to be positive, we write the following equation. ma equals negative mu times mg. We can now get rid of the m on both sides of the equation, and we are left with this. Acceleration equals negative mu times g. Notice that the mass does not play any kind of role in the acceleration in this case. That negative just means that it points to the left. Now, let's go to the case where the object is not moving. We call this the static case. So now our crate is not moving on the ground, but someone is tugging at it to get it to move, with this force vector. We can break our force vector down into x and y components. In this case, friction will oppose the forces that are trying to accelerate the box from rest in the horizontal direction, since that is the direction of the surface. It won't try at all to stop the box from moving in the vertical direction. Now, the static friction force is a bit weird. It does not have a set value. Rather, it applies whatever force is required to stop the box from accelerating. However, it does have a maximum value, given by the formula mu times n. If the forces trying to move the box exceed this maximum, then the box will move, and we will return to the kinetic case of before. Very important point though, the coefficient of friction in the static case is different than the coefficient in the kinetic case. In fact, it is usually larger. Let's see how this works by working out our problem. Now, we look at the F equals ma law in the x direction. ma equals the x component of the applied force, minus the friction force. Now, as stated before, the friction force will adjust to equal the horizontal applied force, thereby canceling it and making zero acceleration. However, there is a maximum value to this friction force. Once the horizontal force exceeds this maximum friction force, then the object will accelerate, and the problem becomes a kinetic friction problem. So in our problem, the object can only move if f sub x is greater than the maximum frictional force, which is mu times the normal force. We already solved for the normal force, so that means it has to be greater than this quantity. If you examine the equation, you will notice that the stronger the upward pulling force you apply, the more friction will be reduced and the easier it will be to move a box. As I noted before, the coefficient of static friction is different than the coefficient of kinetic friction, and it is usually larger. To denote the difference, we usually mark the static friction with a little s, and the kinetic friction with a little k. And that's it for this video.